Hello everybody and welcome back to my YouTube channel. So today we are going to solve a question, as you can see in the heading, that is from coordinate geometry, and that is two vertices of a triangle are 1, 2 and 3, 5. If the centroid of the triangle is at the origin, then find the coordinates of the third vertex. So first, we all need to know what a centroid exactly is. So, centroid of a triangle is the point where all its medians intersect. So, let's try to know more about it. That it is also known as the center of gravity, and the reason primarily because of which it got this name is that, so suppose you take this triangle which I am drawing here, please consider the lines are straight. So now if this is the centroid and if I have put my finger here, okay, suppose this is the finger, so the finger will be able to balance this triangle in such a way that it stands straight. All right, so it would be balanced, it won't be falling on any side, so hence it got its name as center of gravity. So first let's see what it is in a triangle. So I'm going to draw a triangle over here, yeah, and I consider these are the midpoints of its side, and I join them to the opposite vertices, okay, and I get, okay, some kind of a center. So just ignore this, let's this be the center. So, and the point where they're meeting, this point is what we are calling the centroid, right? The centroid. So let me just name this figure as A, B, and C, and the centroid as D. Now, the center of gravity, now in terms of physics and mathematics, it is the average of the positions of all the points of a body, and sometimes you consider it as the center of mass because that it is the center of gravity. And there's a small message, it's from brilliant.org, which says that the centroid of a triangle is the intersection of the three medians or the average of the three vertices, and each median divides the triangle into two triangles of equal area, and the three medians also divide the triangle into six triangles, each of which have the same area. So I've got these triangles which have been formed, and all of them are of equal area, right? So 1, 2, 3, 4, 5, 6, and all of them are of equal area because a median divides it into two equal halves, and from that property we can derive this property. And yeah, that's a property of centroid also. So the first point was very important because from that we can derive our definition or the formula for which we are going to use to solve the problem. And let's move on to that formula. So let's say x1 comma y1 and x2 comma y2 and x3 comma y3 are the coordinates of the three vertices of the triangle. Okay, so it is given to us that this is 1 comma 2 and that this is 3 comma 5, and this is what we need to find. What is x3 comma y3? 0 comma 0, because the centroid is at the origin, and we take the average of the coordinates, that is the average of the vertices. So x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3. Okay, so which is equal to 1 plus 3 plus x3 by 3, comma 2 plus 5 plus y3 by 3, which gives us 4 plus x3 by 3, comma 7 plus y3 by 3. 4 plus x by 3 we'll equate the x coordinates first, is equal to 0. So 4 plus x3 is equal to 0, and therefore x3 is equal to minus 4. Now the y coordinate, so 7 plus y3 by 3 is equal to 0. So 7 plus y3 is equal to 0, and y3 is equal to minus 7. So minus 4 comma minus 7 are the coordinates of the third vertex. Now I have one more thing to show you, that is a visual understanding of what a centroid is and whether the answer, that is minus 4 comma 7 that we got, is it actually correct. I draw the points A, B and C, and then I join these points to form a triangle ABC. Then I draw the perpendicular bisector to AB to just bisect AB and find its midpoint, so that I can join it to the opposite vertex, that is C, and by joining DC I get the median DC. Now I draw another perpendicular bisector to line AC and join E to B so that I get another median. I draw another perpendicular bisector of BC and I got the midpoint of BC, and I joined it to A, that is the opposite vertex of that part of the triangle, and I got the third median. So I mark that point N where the medians are intersecting, and I hide these so that it's more clear to us of what the figure is. So I'm zooming it out, and you see that the three medians are actually intersecting at the origin. So yeah, they're intersecting at the origin, and it's a very complicated triangle, and they intersect at the origin, and that is what proves that what we got the answer as is correct. And if I zoom it in, I get that it looks like a 1D figure from far, a single line, but as I come close, it's actually a triangle.